So in this first example, we're just going to look at the horizontal asymptote from a basic limit of a function and some table of values. So in essence, what they're trying to say is that for this function, as our limit for our values of x are infinitely getting smaller. So if you look on the graph, I'm talking from 0 to the left. As we approach negative infinity along the x-axis, we're saying what is happening to the graph of the function's curve. And as you can see on the left side of this graph, our blue line is getting closer and closer and closer to the value of 1. So on the y-axis, we say that y equals 1. So that's getting closer and closer to 1. And as you can see from the table of values, that the greater the value or the smaller the value, we are approaching the same solution. The output is getting closer and closer and closer to 1. So we would say that as x, the limit as x is approaching negative infinity, or as the limit of x is approaching positive infinity, we are reaching 1. The limit is 1 because it is approaching the same value. So from the left or from the right, we're approaching the same value, and we are calling that value our horizontal asymptote. From algebra, you may remember discussing end behavior. So we were looking at the end behavior of a function's curve, of graph's curve. So we weren't worried about all of this. We were looking at what's going on at the end behavior. And they said that if you have some function, and our professor already said that you're not going to be allowed to prove this on your questions by using this analysis, but if we were to look at some function, f of x, and I'll bring this one down, so x squared minus 1 over x squared plus 1, end behavior is always the highest power lead term. So in this case, it would be x squared over x squared is really how this graph is going to behave. So if we have x squared divided by x squared, you can immediately see that no matter what our input is, we're going to get 1. And what that also tells us is that our end behavior of the graph should get closer or closer, or never get any higher than 1. And that's exactly what we see, is that as we input our values and they get greater and greater or smaller and smaller, we are approaching 1. So it is a way that you can check your function, if it is a rational function or polynomial, it works the same to find the end behavior. But essentially what we want to do later on is, by using a system, a mathematical system, we will find that end behavior of the limit as it approaches negative infinity or positive infinity. So I hope that helps, and thanks for watching.